Okay, so let's do question number 6 now. Okay, in question number 6, we're given that x and y are independent random variables with distribution p0 1.6 and p0 2.3 respectively. First question is find p bracket x plus y equals to 4. In the second question, we are given a random sample of 75 values of x is taken. State the approximate distribution of the sample mean, comma x, comma, including the values of the parameters. Third question, we have to find the probability that the sample mean is more than 1.7. And the last question basically says, explain whether the central limit theorem was needed to answer part 2. Okay, so let's look at the solution. Okay, so in this question, we know that x is a Poisson distribution with 1.6 and y is also a Poisson distribution with mean 2.3. So you have to find px plus y equals to 4. So before we find px plus y equals to 4, we find what's the... Okay, as you know that the sum of the variable which are independently a Poisson distribution, the resultant sum is also a Poisson distribution. So that's why x plus y is simply Poisson distribution with mean 2.6 plus 2.3. Okay, so therefore x plus y, that's our new variable, has a Poisson distribution with mean 3.9. Okay, now we know the lambda for x plus y variable, which is 3.9. It's just a matter of substituting in a formula for the Poisson distribution. Now, as you can see here, px plus y equals to 4 equals to e to the minus lambda x plus y over x plus y whole to the, x plus y factorial. So we know lambda, we know x plus y, we can find the solution then. So your answer is 0.195. You simplify this one and then you get that. Okay, so now in question number 2, we are basically looking at the question where we are asked to approximate the distribution of sample mean. So if you want to approximate a sample mean, then in this case the approximation would be a normal distribution with a mean of 1.6 and the variance of 1.6 over 75. So now the reason is as follows: as x has a Poisson distribution and n is large enough so that we can say that x bar has a normal distribution. Okay, that's basically the statement of central limit theorem. Okay, so in the next question we basically have to find the where the sample mean probability where the sample mean is bigger than 1.7. Okay, so we follow a normal distribution method of solving. So which means in this case you take it into standard variable z and then you use the formula here. So this is x bar minus x minus x bar over the standard deviation, and after you standardize you get pz is greater than 0.685. solve it for this and then you get 0.247. okay, so then you get that as the value here, 0.247. And this is the diagram representing how to find this probability of C greater than 0.685. Okay, and the last question basically is saying if the central limit theorem was needed or not. Of course we needed central limit theorem. Why? Because we know that x was not a normally distributed variable, right? That's why we needed a central limit theorem.